All right, so there's our proof that we're going to tackle. We're going to use one of the triangle congruencies in here. So I remember my options, I'll write them down over here in the margin. Side, 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 angle, angle, side, angle, angle, side, and hypotenuse leg. All right, let's make sure my givens are marked. So let's see, here are my two parallel lines. Here are my two perpendiculars. I'm going to put some numbers in here so we can talk about them, because we do have to be kind of formal about this in the proof. Angles 3 and 4, they're both right angles, right? So they're going to be congruent, yeah. So that's one of my angle pairs. Remember, I need 3 facts. All 3 of these things require a fact. I have right triangles, too. So that means it might be hypotenuse leg. Might be. I won't know until I actually, Hypotenuse leg is the situation where you've got 2 right triangles, and you know that one pair of legs is congruent, and the hypotenuses are congruent. But there's still 3 facts: angle, sides, and sides. So this might be a case where I can use hypotenuse leg. Do I know anything based on these 2 lines being parallel? Can I draw anything from that? Why? Okay, 1 and 2 are alternate interiors and therefore congruent because of the parallel lines. Okay. 3 and 4 would be if AB was parallel to BC. So that's not given. But I do know 3 and 4 are congruent because they're both right angles. The right angle theorem tells me that. So that's 2 angles. Do I have any sides that are congruent? A side would be useful. All of these require at least 1 side. So is there any side congruent between the 2 figures? AD and BC. They're not marked as congruent. It's not given as congruent. Which one? AC is congruent to what? Oh, yeah, that's right. Whenever you have a shared side, it's always congruent to itself by reflexive. So if I look, I've got my 3 facts, don't I? I've got 2 angles. So this pair of angles, this pair of angles. So I got my 2 pair there. And I've got 1 side. That's 3 facts. As long as it's not side-side angle, you're good. So it looks like I'm going to be using, okay, which one is it going to be? Angle, side, angle, or angle, angle, side? Angle, side, angle. Here are the 2 angles and the sides nestled between them. So let's go ahead and write out that proof. Let's see. Start off with my givens. AD is parallel to BC. Before I write down anything else, I'm going to write down what that tells me. That angle 1 is congruent to angle 2 because they're alternate interior angles. Let's write down my other givens. AB is perpendicular to AC. BC perpendicular to AC as well. That tells me that I've got 90-degree angles. That's by the definition of perpendicular. Based on the way I wrote my proof, this blank has a lot of options. I'm going to write the right angle theorem. Measure of 3 is 90. Measure of 4 is 90. And that comes from them both being perpendicular. You could also, and this is where the book's a little fuzzy with these proofs. You may also write angle 3 and angle 4 are right angles because of perpendicular. It's not very clear which is the specific result. All of them are kind of possible parts of the definition of perpendicular. So there's a little flexibility here. If I were to be grading you guys on a from-scratch proof of this theorem, I would pretty much say anything here that makes sense based on saying they're perpendicular works. especially if it can then lead you into the idea that 3 and 4 are therefore the same measurement. You could even, I suppose, skip this step and just write 3 is congruent to 4 by the right angle theorem, because that is part of being perpendicular, but it's a little bit, that's a big contraction. That's a little bit cheating. That's almost like writing a sentence or two on wildcats. I know what you mean, but Walsh would have your head on a pike for it. Now, if I look back at this, the last thing I got to say now is that AC is congruent to AC by the reflexive. And therefore, my triangles must be congruent by angle, side, angle. The other thing you'll notice as we work our way through these proofs is that angle, angle, side just doesn't come up very often because it's usually easier to get angle, side, angle out of it. You have to really work to set up an angle, angle, side kind of situation. So I would always make that my last guess. If you had to make a guess, I would pick that last. Also, again, reiterating, this guy has right angles in it. Let's keep this down for a second. And it's not hypotenuse like. Now, it might be. We'll do one that is, so you can see the difference. But just get over that hump now. I've had a lot of students who've done that over the years. It's their go-to answer is to say, oh, there's right angle must be hypotenuse like. And you don't want to fall into that trap. What can I say about this proof? What steps lose you? It's okay to get lost. We're still getting the hang of this. I'm going to put this one in the can then.